Welcome to Activity 2.1. You should be on page 16. And if this is your first one, what you're doing is you're going to be taking evidence. You might say, what do you mean by evidence? Well, on page 17 or on page 16, what you need to do in the first column is explain the phenomenon. What do you know about it? You need to take notes, and you should be able to fill in these boxes. They're not very big. And then you should be able to explain how what you've learned helps you understand the Earth in the distant past. And I'll help you with that as well. Now, I am going to tell you that this is one of the key pieces that you're going to have for the test. If you take really good notes, this will help you on the test. It'll help you do much better. And the test is, it's not obviously going to be this week. It's the end of the week. And I don't think, it might be towards the end of next week. We're getting close to where we're taking that first test for this book. So, glacial evidence. So this is the third box down. So a glacier is a large, slow-moving, solid body of ice. Glacial ice can be very thick and extremely heavy. And as the ice flows downslope, it causes friction along the bottom where the ice melts and the underlying rocks melts, and it meets the underlying rock surface. Now, the friction between the glacier, what it does, it'll crush, it'll scrape, and it'll move rocks. So it picks the rocks up and it drags them along the surface of the earth, similar to a river, causing the underlying rocks to become weathered and eroded. Now, this can cause large, wide valleys to be carved. And a glacier moves less than 1 mile per year, so they don't move very fast. Whereas water in a river might move, well, they might move 5 miles in an hour. Now, after the ice melts, scientists can determine the direction of the ice. So they look at the grooves and they can figure out in which direction the ice was moving. Now, if you're thinking, oh, I can relate to this, I live here in Baraboo, and you probably can. Now, again, a lot of you think I'm old enough to be around, or was witness to the glaciers, but I'm not quite that old. But the glaciers once did cover the area that the middle school is located on. And the glacial ice in Wisconsin may have been up to 2 miles thick in some areas. And some of you may think that the glaciers created the bluffs, but the bluffs were not created by the glaciers. The bluffs were created well before the glaciers came through. Now, we also have some glacial striations. If you go out to Devil's Lake State Park, there are some areas where you can see evidence of these glaciers and the glacial striations or grooves. So here you see it's called striations, and the mystery of the far-flung fossils, they call them grooves. So during very cold periods on Earth, like the most recent ice age about 10,000 years ago, and again, that's the one that came down into Wisconsin. Not all of Wisconsin, but quite a bit of Wisconsin. Now, scientists, including Wagner, looked at the direction on Earth where evidence of glaciers could be found, and they discovered that about 300 million years ago, much of North America was covered in a very thick sheet of ice, as were parts of South America, Southern Africa, India, and Southern Australia. Now, how could places that are very arid now, such as Africa, have once been covered with ice? So let's look at this and think back to your puzzling Pangea, or your mystery of the far-flung fossil. Think of India. India now is not too far from the equator. India is not a cold place. And if you look at the glacial grooves or the striations in southern India, they point, or they show that the glacier was coming from the south north. So in other words, not only did India have these striations when it's much too hot to have glaciers nowadays, but the glaciers seem to be coming from the equator. How could this be? How could we have glaciers forming, one, over the Indian Oceans? Glaciers typically, they're over continents. That's why they call them continental glaciers. So India is a really big puzzle. And same thing with Africa. If you look at where they were found in Africa, if you go back to the mystery of far-flung fossil, and even South America, they seem to come from the ocean. Africa, they seem to come from the ocean. What's going on? How can this be? Well, again, so that's your phenomenon. Having these glacial grooves in North America, I can understand that. But some of these other places, like southern Australia, again, a very hot climate. It's not cold at all. How could this be? So how does this help me understand the Earth in the distant past? Again, if we go back to Wagner's idea of Pangea, and knowing that all these places were once connected, it would make sense that the glacial grooves or striations go off in different directions. But not only that, when they were together, they were probably located pretty close to the South Pole. And they weren't up where India is today, but rather India was probably much further to the south. So again, this helps to support Wagner's idea of continental drift, that the glaciers did indeed form, because we have the evidence, but not where the continents are today, but where they were in the past. So they were together, but in a much colder location.